All right, we're going to look at some of the equations that go with electricity today and talk about how much electricity costs. We'll get there eventually. So you're probably wondering after the last videos, how did Mr. Dewey take 10,000 volt shocks and still live when something like this outlet has 120 volts, and if I stuck a fork in the outlet, probably wouldn't go very well for me, or if I were to put a toaster in the bathtub with me, that would be the end of Mr. Dewey. So how do I take 10,000 volts? Well, an important saying to remember with electricity is volts don't kill you. Amps do. So what is voltage? Voltage is really just a measure of how badly, this is not a technical definition now, charge wants to flow. And that's based on the difference between 2 points. So these two outlet prongs would have a difference of 120 volts. It doesn't really matter how much charge something has, it matters about the difference between one point and another point. So that's why birds can land on a power line, because they're not touching anything else with a different potential. So voltage is about how badly charge wants to flow. Amps, which is really the unit for current, that's why it's easy to remember, like the current of a river, is how fast charge actually flows. It's a rate. It is the rate of flow of charge, flows, in coulombs per second. So 1 coulomb per second is 1 amp. We'll keep that in mind. And finally, there's something called ohms, which is the measure of resistance to the flow of charge. It's usually some sort of friction in your electrical circuit that resists the flow of charge and turns that electrical energy into heat energy. So things like the element in your oven or in your toaster, things that tend to glow are really resistors. Even a light bulb an incandescent light bulb is really like a resistor. So these are all related by something called Ohm's Law, which is the most important electricity equation. Twinkle, twinkle, little star, V is equal to IR. That's how my 9th grade science teacher taught me it, and I always remembered it since then. So I is current in amps, and that's the thing we really care about. R is resistance in ohms, and V is voltage, sometimes called potential difference, and that's measured in volts. So for example, with the Van de Graaff generator, if I wanted to find my current, I'm going to do I equals V over R. V was about 10,000 volts, because that's how bad electricity has to want to jump. In order to jump an inch, it takes 10,000 volts. And I just looked it up. A dry human wearing rubber-soled shoes has about 100,000 ohms. So I only had about 0.1 amps flowing through me, which I felt, but it takes like 1 amp to stop the heart, so I wasn't in any real danger. All right, I mentioned that voltage was a type of potential. It's actually the potential energy per charge. So the units that we use, volts, are really joules per coulomb. Whereas amps is a rate of the flow of charge, so it's coulombs per second. So what would happen if you took amps times volts? You would get coulombs per second times joules per coulomb, which is joules per second. And a joule per second is the rate at which work is being done, or the rate at which energy is being converted from one form to another. In this case, it's going to be electrical to something like heat or light or sound or who knows, mechanical. So joules per second, we've had that unit before. That is the watt. The watt is the unit for power. And it's a rate as well. It is the rate at which work is done. So we can say power is amps times volts. So if Ohm's law was the most important electricity equation, V equals I times R, P equals I times V is the second most important one. We're going to use that equation all the time.